Polarization of non-polar dielectric in an external electric field. Now we have a non-polar dielectric material, and as we have defined, non-polar dielectric materials are the substances in which center of gravity of positive charge coincides with center of gravity of negative charge. So as both the charges are coincide with each other, so net dipole moment on a molecule is zero. So molecule is non-polar in the nature. Now we have a non-polar dielectric material, and inside that non-polar dielectric material there are many non-polar molecules are there. Now if you observe figure 8.20, it shows that non-polar dielectric is placed in the absence of electric field. Then what is the effect of electric field on the non-polar molecules? Now, as non-polar dielectric substance is placed in the absence of electric field, so center of gravity of positive charge remains coincide with the center of gravity of negative charge. So there is no charge separation, and as there is no charge separation, so electric dipole moment remains zero. So non-polar molecule is present within the dielectric material, so we call material remains as a unpolarized. Now we apply external electric field to the non-polar dielectric material. So if you observe figure 8.20b, it shows that non-polar dielectric material is placed in an external electric field. So value of external electric field E0 bar is not equal to 0, right? Means there is some external electric field is always present, and we place non-polar dielectric material in the external electric field. So what will happen? Electric field is a flow of electron, and we place non-polar dielectric material within that external electric field. So the external electric field will exert a force on the positive charge and negative charge. But as we know that positive charge is always attracted towards the negative charge, and negative charge is always repelled from the negative charge. So negative negative repulsion is there, and positive negative attraction is there, and we are saying that external electric field is the flow of electron. So positive charges get displaced in the direction of external electric field, whereas negative charges get displaced opposite to external electric field. Because of this, there is a charge separation between the negative charge and positive charge. As positive charge and negative charges are separated from each other, so small finite distance always exists between the positive charge and negative charge. As small distance always exists between these two charges, so dipole moment is exist. Value of dipole moment is now non-zero, and as value of dipole moment is non-zero, so we say that non-polar molecule, non-polar substance is now converted into a polar substance. Next is polarization of polar dielectric in an external electric field. Now, as we have already discussed, in case of polar dielectric molecule, center of gravity of negative charge does not coincide with center of gravity of positive charge. Positive charge and negative charge are separated from each other. So there is always some finite distance existing between the negative charge and positive charge. So each single molecule has a permanent dipole moment. Now when we consider polar dielectric substance, in the substance there are large number of molecules are there, and we are considering polar dielectric substance. So within that polar dielectric substance there are many molecules are there, and all the molecules are polar in the nature, because there is always charge separation exist between two opposite charges. So charges are always separated from each other by a small finite distance. Now each single molecule has a permanent dipole moment. But when we consider overall polar dielectric substance, all the dipole moments are randomly oriented, and as dipole moments are randomly oriented, they cancel with each other, and as dipole moments are cancel with each other, so net dipole moment on the material or on the substance is zero. So material is unpolarized. And why it is unpolarized? Because dipole moments are oriented in such a way that they are cancelling with each other. So this is our figure 8.21a, which shows polar dielectrics in the absence of external electric field. Now when we place that unpolarized polar dielectric substance in an external electric field, value of external electric field is non-zero, then all the dipole moments of all the molecules get aligned in the direction of external electric field. Positive charge is displaced in the direction of external electric field, whereas negative charges are displaced opposite to the direction of electric field. So now in this case dipole moments are in same direction for all the molecules. As all the dipole moments are in the same direction, so they get added with each other, so net dipole moment always exist. Now in this case, as value of net dipole moment is non-zero, so we can say that unpolarized polar dielectric material is now converted into polarized dielectric material. Figure 8.21b shows effect of external electric field on the polar dielectric material.